These are video notes on finding surface area. We're going to start off by finding surface area of prisms. And just as a quick definition, surface area is when you take the area of each face on the prism and you add it up. And that could work for any type of a three-dimensional shape. We're going to start off with rectangular prisms, and we're going to come up with a formula that we can always use for this. In the figure on the left here, we have width, length, and height all labeled. Those are labeled using cursive letters, mostly because of the length. L can often look like a 1, so when we're talking about length, you're often going to see a cursive L used for that. So remember that surface area is when you find the area of each face and you add it up to find your total. On this rectangular prism, we have 6 faces. I'm going to start off by looking at this front rectangle right here. The dimensions of that are length and height. So if I want to find the area of that rectangle, I'm just going to multiply length times height. So this is going to be the start of our surface area formula. Okay, that's going to give me the front piece of, or front face of that prism. Notice that that is going to be identical to the one in the back. So I'm actually going to have a second length times height to represent the back. Okay, now we're going to move on to this rectangle right here, which is on the bottom of the prism. And the dimensions are width and length. So if I want the area of the green rectangle, I'm going to multiply width times length, and I'm leaving some spaces in there. We'll go back in a minute. The bottom is going to be the exact same size as the top, so they're going to have the same area. So I'm going to have a second width times length for the top. And then our final two sides, final two faces are the left and the right side. Those two are going to be identical to each other. So the dimensions that we're going to multiply for area are width times height. So we've got height times width, and there's 2 of those. Height times width. So now when I look at them together, I have a total of 6 areas, and to find surface area, I'm just going to add all of those together, add up all 6 areas to get total surface area. Now that formula will work, it's perfectly fine, but it's a little bit long, so we can actually condense things just a little bit. If we know that the front and the back are the same, left and right are the same, top and bottom are the same, we can actually combine all of our like terms. So length times height plus length times height, there's 2 of those, so I can just do 2 times length times height. And then we can do the same thing for width times length. There's 2 width times lengths, and there are 2 height times width. So still a valid formula for surface area. And now instead of adding all 6 faces, we're going to add each of the 3 different faces twice. So that would be our final formula for surface area. And again, this is only for a rectangular prism, so only for figures that have 6 faces that all fit this criteria. All right, now that we have our formula, let's take a quick moment to review our 4-step process for using a formula. So very first thing, you're going to copy the formula. Then you're going to plug in the numbers that you know. Then you get to do the math, and then number 4 is just your reminder to make sure you have the correct units. All right, here is our first example. We're going to find the surface area of the rectangular prism, so we're allowed to use this formula. So step 1 is already done right here, writing the formula. Step 2, I'm going to plug in all the things that are given to me. So let's actually take a quick moment to label our length, our width, and our height. The height is going to be our vertical distance right here. And again, this is just for your rectangular prism. You can identify it that way. And then in terms of knowing which one's width and length, typically your width will be your shorter measurement and length will be your longer measurement. So we can label them. I would suggest that you do that. It just makes the plugging in part a lot easier. Okay, so step 2, we have 2 times length, which is 10, times height, which is 1, plus 2 times the height, which is 1, times the width, which is 5, plus 2 times width times length. So step 2, I'm just substituting in those values. Now on step 3, I can start to combine things. Order of operations tells us to do all of our multiplying first. So 2 times 10 times 1 is 20. 2 times 1 times 5 is 10. And 2 multiplied by 5 is 10, times 10 again is 100. And then we can go ahead and combine these together to get a total surface area of 130. Okay, step 4 tells us to put units on this. So since we're talking about area, that's going to be square feet. So we can do feet squared, and that represents our 4th step. And then you could even label step 4 down there like that. All right, those are all the steps that you're going to need to show whenever you're using the formula for surface area. Let's look at another example. So same idea, we're going to start with our formula. So step 1 looks just like that. Step 2, we're going to plug in all the measurements that we have. So we'll label 7 is the height, 3 is the width, and 6 meters will be the length. So now when we plug those in, we'll have 2 times 6 times 7 plus 2 times 7 times 3 plus 2 times 3 times 6. And then just like before, we'll go ahead and do all of our multiplying before we add. So for the first set of multiplication, that's going to become 84. Second set is 42. Third set is 36. And then all together, when you add those 3 numbers, you're going to get 162. So surface area is 162. This was actually step 3 here. And then that's going to be meters squared. So step 4, check to make sure that we have our units. All right, next one. What's the least amount of wrapping paper needed to wrap a gift box that measures 8 by 8 by 10? So let's start by labeling all of those measurements. For the base, we can have 8 inches for each of those and a height of 10 inches. And then while we're at it, we'll go ahead and label height, width, and length. Since those are the same, we can label them either way. All right, step 1, start with our formula. And then for step 2, we'll plug in what we know. So surface area is going to be 2 times 8 times 10 plus 2 times 10 times 8 plus 2 times 8 times 8. And when we do that multiplication, for the first 2, we're going to get 160. And then for the third multiplication, we're going to get 128. And then all 3 of those added up will give 448. And then this is in square inches. So final answer, least amount of wrapping paper, assuming that you're not overlapping, which you probably are, but assuming you're not, 448 square inches. All right, so now that we've done a couple examples with rectangular prisms, we're going to move on to triangular prisms. There is a formula that you can use. It's in your agenda. You can look it up online. But for this one, I'm going to show the example breaking it apart into the 5 faces. You could do this for the rectangular prism, but the formula seems to be just as structured. So for this one, I have 5 faces. I have this front, or kind of to the left side, green face, and the dimensions of that one are 3 by 6 for the rectangle. So in green, I have a 3 times 6 rectangle. Then in blue over here, I have another rectangle that is a 4 by 6. In the back, I'll outline it in black right here, I have that rectangle, which is going to be 5 by 6. So this 5 up here gives that dimension across. So a 5 by 6. And then we have 2 triangles. So we have this top triangle and this bottom triangle. Area for a triangle is base times height divided by 2. This right angle symbol right there tells us where the length and height are. So we're going to be using 3 and 4 as our length and our height of the triangle. So I have 3 times 4 divided by 2. That could be my top triangle. And then since I also have one on the bottom, I have 2 of those, so I could use that expression. If you work that out, 3 times 4 is 12. 12 divided by 2 and then multiplied by 2 is still just 12. So this is going to simplify down to 1, and we're just going to have a second set of 3 times 4. So if I want to write it as a formula, it would look like this, where I'm adding up each of those areas. And then if it helps, you can sketch out what each of those shapes would be. So I had a rectangle for the first 3, and then in red, that represented each of my 2 triangles, and I put those together, so that shows all 5 of my pieces. And then from here, we'll go ahead and add up, or multiply and then add up. So I've got 18 plus 24 plus 30 plus 12. And then all together, that's going to be 84. And then final step is to check units, which would be meters squared. So 84 meters squared for the triangular prism. And then once again, this is super important. You cannot use your rectangular prism formula for triangular prisms. It'd be like trying to find the area of a circle by doing length times width. It will not work. So we'll do one more example where we split apart our triangular prism to find surface area. So this time, let's start with this rectangle right here. So I have that rectangle. I'll structure this one a little bit differently in case you're more visual. The area of that one is 3 times 5. So that area is going to be 15 square centimeters. Then I've got this rectangle, which is a 4 by 5. So 5 and 4 for length and width. So for that rectangle, I have an area of 20 square centimeters. Then I have this kind of slanted face over here, and that one is going to have a length and a width that are each 5. So that area would be 25. And then I have my triangles that are on the front and the back. So remember, this right angle symbol here tells us to use 3 and 4 for our length and width. So for each of those triangles, I'm going to have length times width, which is 12. 3 times 4 is 12, divided by 2 is 6. So now I have two triangles, each with an area of 6 square centimeters. And then we can add up area of all 5 faces. And that sum will be 72. And then final step on that, we're going to add centimeters squared. So once again, rectangular prism, you could split it out like this if that helps you. Label each of your 6 different faces, or you could use your formula. On triangular prisms, while you're just getting started with it, I would suggest using this method where you label each of your 5 faces, and then as you get more and more comfortable with it, if you want to check out the formula for triangular prism, you can go ahead and do that. All right, thank you for watching, and good luck with finding surface area.